All right, we're going to do this question for 9.3 review. So the question gives us a equation, and we are going to find the y-coordinate of the highest point. Now what this is going to require to do is find when dy is equal to 0, right? dy is our slope, and if we graph this r equation, it looks something like this. So the highest point is going to be here, and the line tangent to that is going to be horizontal. So we want to set the slope equal to 0 to find a horizontal tangent, and where it touches is going to be our y-coordinate. So when we solve for this, what we're actually solving for is some degree in radians, and when we plug this degree into dy, we get 0. So once we find what the value of our theta is, we're going to plug it into our equation for y, which if you remember is this, and plugging this found value into our y will give us our y-coordinate. So let's go ahead with that. So y is going to be equal to sine of 2 theta sine. And x is going to be equal to sine of 2 theta cosine. We're going to need to use u prime, so I'll write that down. That's going to be equal to 2 cosine 2 theta. So now we need to do our dy dx, and this is going to be the derivative of this over the derivative of this. So let's do that. It's going to be in a form of r prime sine plus r cosine over r prime cosine minus r sine. So you might have seen this before. This formula is accounting for the fact that when you differentiate x, cosine is going to become a negative sign. So that's why that is there. If you don't remember this formula, it's basically product rule on top divided by product rule on bottom. But this is the shorthand of it. So let's plug that in. We have 2 cosine 2 theta, that's our r prime, times sine theta, plus sine 2 theta cosine theta, all over 2 cosine 2 theta, that's our r prime, cosine theta, minus sine 2 theta sine theta. So you can see here I'm using this form, and this is our r primes, and these are our r values. So let's try to simplify this. This is equal to dx. That is what that is, or dy dx. So we want to set this top portion to 0, but that answer is not very intuitive at this moment, so let's simplify as best as we can. So there's a couple ways of doing this. One, let's notice that sine of 2 theta is equal to 2 sine theta cosine theta. So we can sub that in here. Cosine 2 theta is equal to a couple things. It's equal to cosine squared theta minus sine squared theta. And it's also equal to 2 cosine squared theta minus 1. So let's rewrite it with those substitutions. The first one, we will substitute, I'm going to demonstrate both equations. So the first one, we'll use that cosine squared theta minus sine squared theta in substitution of our cosine 2 theta. And then we're multiplying by sine theta. This is our r prime times sine. and it's r prime using the trig identity of cosine 2 theta. And then I'm adding sine of 2 theta. We're going to use the identity 2 cosine theta sine theta. And then this is multiplied by cosine theta. I'm going to put this all over. We're going to do the exact same thing on the bottom for the identities. And now it's just up to simplification. So let's simplify a bit here. Whoops. Be straight. All right, clearly this is too large. Just erase a little bit. So let's simplify this by multiplying out and then factoring out any like terms. So we have 2 cosine squared theta times this sine theta. Then we have minus 2 sine squared theta times this sine theta. So this will be sine cubed theta. Then I'm going to add 2 cosine squared theta sine theta. So it's this times this gives us 2 cosine squared theta sine theta. Put that all over. It's going to be 2 cosine cubed theta, because this times this, minus 2 sine squared theta cosine theta. And then I'm subtracting 2 cosine theta sine squared theta. So now you can see we have some more simplification to do. These two terms will meld together, and so will these two. So we have 4 cosine squared theta sine theta minus 2 sine cubed theta all over 2 cosine cubed theta minus 4 sine squared theta cosine theta. I want that back again. Okay. So now let's do some more simplification. Let's factor out a 2 sine from the top, 2 sine theta from the top. If we factor that out from here, we'll be left with 2 cosine squared theta minus sine squared theta. And if we factor it out from the bottom, we can do 2 cosine theta. And then that'll leave us with cosine squared theta minus 2 sine squared theta. So a little tip, I haven't actually applied that tip here, but you really only need to be worrying about the top here. So like, you know, it's just extra work to do the bottom. You know, that's a good tip. I should stop doing that. Anyway, this is our new equation that we have here. And this needs to be set equal to 0. So let's rewrite it. We have 2 of sine theta times 2 of cosine theta, cosine squared theta, minus sine squared theta. And that equals 0. So we need this term to equal 0 or this term to equal 0. Now at sine equals 0, well, that would be theta equals pi over 2. Nope, I mean 0 or pi or 2 pi, or really any k amount of pi. It's any integer of pi. It's going to equal 0. So if we plug that theta back into our original equation and solve for y, well, y would be equal to 0. and our graph extends above 0. So while that may be an answer, it's not necessarily the answer we want. There must be another solution for theta so that this equation equals 0. And what we can do is evaluate the right term, the second term of this equation, which is 2 cosine squared theta minus sine squared theta equals 0. So let's solve this equation. I'm going to start by adding sine squared theta on the right side, and then divide both sides by cosine squared theta. So we get 2 equals sine over cosine's tangent, 2 tan squared theta. Then let's take the square root of both sides, and we get the square root of 2 equals tangent theta. So this means that theta will be equal to the arctangent of square root 2. So now this is our answer, and I'm just going to plug that back into our y equation, and that should give us our final answer. It looks like the homework assignment does this in a very elegant way that allows it to be expressed in exact terms rather than a long decimal, because arctangent of square root 2, I don't think that that's like a nice number necessarily. 0.9553172. I don't know if that's an angle measurement that we know in radians, but I'll show you how the homework does it. So it's recognizing that y is equal to 2 sine 2 theta times sine theta, and then it does the identity for sine theta, so then y is equal to 2 sine theta cosine theta times sine theta. So y is equal to 2 sine squared theta cosine theta. It's using that identity. It's using the equation that we just solved. And then the Pythagorean identity. So personally, I wouldn't bother with the algebra here just because you might get messed up. I would just recommend, since we do have Desmos, or just any calculator, plug this ugly number directly into that equation and get your answer. I'm trying to see how they would have come to this conclusion just based off these equations. Because I can set 3 cosine squared theta equal to 1, but then that leaves me again with theta equaling arc cosine of root 3 over 3, which is equal to arc tangent of root 2. But yeah, sorry to complicate things here. If you just do y equals sine of 2 times tan of -1 of root 2 times sine of arctangent root 2. That will give you your answer here. And it's great that we have Desmos, because then you can check it. See, you graph the polar equation, then you graph that number, and it'll give you that. But that is going to be the end of this video, and hopefully that's cleared some stuff up. I would hope to assume, I'd like to assume that the exam would only encompass questions that give us nice theta values, and not something ugly like that. But hopefully this makes sense. As a quick review, when finding the highest y value, we want to take the derivative. We want to find dy dx to get the slope, because the highest y value is associated with a horizontal tangent line. So to find the horizontal tangent line, you're going to set dy equal to 0, because we want the slope to equal to 0. A horizontal line will have a slope of 0. Once you've set that equal to 0, you're going to solve for theta. And that might be the whole question, you know, find the slope at theta equals whatever, then you plug that in. But this one, once you find the value of theta, you're going to plug it back into the equation. And then that'll give you the y value. So thank you for watching, and that's the end.